So it says find f inverse of 3. So how did you attempt to do this one? How did you attempt to do this one? What did you attempt to find? Try to find f inverse. So what's the first thing we should do? Well, not solve for y. You solve for x or switch x and y. Either one. Let's switch first and then solve. It's the same mechanics. It's the same mechanics. So x is equal to 3 plus y squared plus tangent of pi x divided by 2. So now, what do you want to be able to do? What's your goal now? What do you want to do next? Yeah, I see. Also the same thing. It's very good. Solve for y. That's what we want to do. What happens when you try to do that? Yeah. Y. Yeah, it's a y right there. Yeah. It is a y. What happens when you try to solve for y? Yeah, you're not going to be able to solve for y. What problem do you run into? What's the structural part of this that makes it really hard to solve for y? The tangent by itself doesn't. You can deal with tangent. The tangent by itself does not cause the problem. What causes the problem? What? The tangent by itself doesn't cause the problem. Okay, I'll be more specific. This by itself you could solve if that equaled something. What's the problem? The y squared alone is not the problem. What? Together, yeah. You have a y, you have a variable inside a trig function and where else? And outside the trig function. To make this even more simple to see, could you solve this for me? X sine x is equal to 3. Do you even have a method of solving that? No, you don't. So you get to here and you want to solve for y? Can't. You don't have the algebra to solve for y. So what is your option here? One of the questions, go back I think to 16 or 17, it says something like f of 2 is equal to 9. So f inverse of 9 is equal to? 2. So you're trying to solve f inverse, so you're trying to solve f inverse of 3 is equal to something. That's the same thing as what? Equals 3. F of what equals 3. So what do you need to solve then? 3 equals what? 3 equals f of x. And what is f of x? What is f of x? 3 plus x squared plus... There it is. So now we solve that. Cross out the 3 and end up with x squared plus tangent pi x divided by 2 is equal to what? 0. Again, what's the problem with this? What makes that really hard to solve? X and in and out of the trig function. Right, so what are you going to have to use to solve this at this point? You're going to have to use your calculator. What do you mean it satisfies? If it's in the domain, it means you are allowed to do what? If a number is in the domain, you're allowed to use it, exactly. So as long as x is in the domain, that's true. What happens if you try to plug a number that's not in the domain into a function? Something's not going to work. Either you're going to have it divided by 0, or the square root of a negative number, or maybe something else that we haven't even thought of that you can't do, or some combination of those two things. Absolutely. Okay. Any last questions? Anything else from the homework? I'd imagine there are a couple others at least. 19, there it is. And now that you've done this one, does it get a little easier? I think so. You don't like E? What is E? Euler's number. It's just a number. It's like pi. It's an irrational number. It occurs in the natural world. It's called the natural number. So on this one, it goes find G inverse. So you could, theoretically, what could you try to do on this? Yeah, try to isolate y when you have something like this, right? Is that hard? Why? Yeah, we know. We can't isolate. Why is it really hard to isolate? Yeah?
E to the y.
Well, no, if it was just e to the y, you'd be okay. This is the same reason as before. It's a combination of having things down in the base area and having a power. It gets really nasty. But what do we have to answer here? If this is the function, y equals 3 plus x plus e squared, e to the x. If we want to find g inverse of negative 4, what do we have to solve? 3 plus x plus e to the x equals 4. You solve it, you want to know when it equals 4. Because look, if you know g of x is equal to, you want to know what g inverse of 4 is equal to question mark, which means that g of question mark is equal to 4. So we need to find out g of what is equal to 4. How do we solve this? X plus e to the x is equal to 1. Now, it is possible to do that in your head. It is possible, but can you do it algebraically? What do you think? Could we do it algebraically before? On the last question, could we use algebra? What? We did? We used algebra on the last one? I thought we used our calculator right here. No. So on this one, what do you have to use? Use your calculator again. Sure. And what was it? It was x plus what? Second. Right there. Oh, that's not the right one. Second e to the. And what's the other thing we need to have it intersect with? 1. It's this. X plus e to the x equals 1. So we graph this. There it is. And boom. Does it intersect? Where does it look like it intersects? 0, 1. Yeah. X is 0, y is 1. How can we get a little bit more confident on that? You can do the intersect. First curve, second curve, guess. Oh, what is the intersection? Oh, look at that. So in this case, the intersection point is 0, 1. There you go. It's a good time. Okay, any last questions on the homework? Any last ones you want to bring up? Anything else? The other ones go okay? Were they decent? Yeah? Okay, that's good. That's actually really good. Yes, you need to understand it. Absolutely. You absolutely need to understand it. Read it a couple times. You got the formula for Celsius equals something in terms of Fahrenheit. Fahrenheit is greater than or equal to negative 459.67. Does anybody know what that number is? What's that called?
I feel like I know what it is. I learned it in chemistry.
It's absolute zero. What happens? I have a question to you. What happens at absolute zero?
Nothing. We just stop.
End of the world. The thing is, have we gotten pretty close to absolute zero? Have we ever brought anything down close to absolute zero? Yeah, we have gotten stuff really, really, really close to absolute zero. But ever managed to get something to absolute zero? As far as I know, no. It's kind of an interesting thing to think about. Absolute zero means no atomic movement. The thing is, I don't know the theory behind all of it, but you're talking. Do you know how they get things that cold?
No.
It's really neat. They have these containers where the substance is being magnetically held like in the center. It's not actually in contact with anything solid. But the thing is, it's in vacuums. But is anything totally vacuous? There's always something in there, right? So even if there's like 2 particles in there, they could be moving, interacting with that inert substance that they're cooling, right? It's really cool stuff. Find a formula for the inverse. So what would the inverse formula? What is the inverse formula? Can someone tell me what it is? F equals what? 32 plus what? 9/5 C? You've seen both of these things before. One goes from Celsius to Fahrenheit. The other one goes from Fahrenheit to Celsius. This one, you take Celsius, plug it in, and you get out Fahrenheit. You've probably seen this one more often than the other one because you generally want, I mean, when I say you, Americans, we have a weird system of measuring temperature. We want things to be in Fahrenheit. Find a formula for the inverse. What is the domain of the inverse? How do you find the domain of the inverse? The range of the original. What is the range of the original? Okay. So what is the domain of the inverse function? Well, the domain here, what's the smallest value C could be? Basically, for the range of the inverse, you want to know what the smallest value f can be? Kids, do they give you? What does this represent? What is that? F. You can think of this as x and this. Sorry, this is y, and this as x, right? So you can think of this as the domain of the original, right? So what's the range? How do you find the range? That's the range of the inverse, correct? So they're asking for the domain of the inverse, right? So this would be the range of the inverse. That's correct.
Yeah.
That would be the range of the inverse. We want the domain. So we would need to, how would we go about doing this?
We find the range of the original.
You could find the range of the original, exactly. Find the range of the original. And since it's a linear function, the range is pretty easy to find. How do we find the range of the original? You take this number and you do what with it? You take this and plug it into that right there. Plug it in and tell me what you get.
The minimum.
Yeah, you get the minimum C value. What's a foot? What's a kilogram? What's a second? What's a kilogram? No, what's the definition of a kilogram? Did you know there is the kilogram? I think it's in Paris right now. The kilogram. What does it mean? What is 1 foot? Seriously, how do you define 1 foot? What's an inch? Exactly. Do you understand what we're getting at here, everybody? There is, and there are standard definitions. There are universal constants. There are things that we believe are always universally constant. What are they? Think about it this way. Let's say you had a test. They run a security test or something that could identify potential cheaters, right? Let's say you had a test that was 99.99% accurate, right? It could look at someone's testing history and tell you within 1%, 1/100th of a percent if they were a cheater or not, right? So that means it's wrong 1 out of 10,000 times, right? Meaning 1 out of 10,000 times it identifies somebody as a cheater who is not a cheater. What happens if you run this on 1 million people?
You're gonna be wrong.
1 million divided by 10,000 is what? You have 9 zeros. So you have 6 zeros. Take away 4 zeros. You have 10,000 people. So that algorithm just misidentified how many people? 10,000, right? When you think about 99.9999, think about what that means. It's a neat thing to think about. Okay, the theory of relativity, you can think about tonight. What I'd like